Hello everyone, welcome back to the course. In this lecture, first I am telling you about machine learning classification. Machine learning classifiers are a critically important part of the data science toolkit. However, they are not nearly as important as they are made out to be. A large part of the mystique of data science comes from the idea that we can pour data into a magical black box that can learn everything about the data and solve business problems. The reality is a lot more mundane. As we have discussed, it takes a lot of work to get the data into a form where it can be fed into the black box. A lot of survey to point the black box at the right question and additional work to my sense of the result. Now, what is classifier and what can you do with it? A machine learning classifier is a computational object that has two stages. Number one, it gets trained. It takes in its training data, which is a bunch of data points and the correct label associated with terms. And tries to learn some pattern for how the point map to be labeled. Number 2, once it has been trained, the classifier acts as a functional that takes in additional data points and output predicted classification for them. Now, a few practical concerns. The whole notion of machine learning classification is premised on the idea of having correctly labeled training data and in sufficient quantities afford to train our classifier. However, this is luxury that the real world often does not afford. For example, in fraud detection, you will probably have a modest size set of hand labeled fraud causes and a huge much of unlabeled data. You just presume that those unlabeled points are non-fraudulent, which means that an unknown fraction of your training data is mislabeled. It is not like the hand labeled fraud causes are a nice random sample from all fraud cases. This represents whether kind of fraud people have been looking for so far. This could easily be whole new categories of fraud, every instance of which is labeled as non-fraud in your training data. Now binary versus multi-class. Most classification problems have a binary classification 1 or 0, yes or no. However, oftentimes the label is a categorical variable capable of taking on several values. There are some classification algorithms that handle this situation natively, but many others are strictly binary. When you are using a classifier that is binary but solving a problem that has k possible labels, the standard solution is to actually train k-defined classifiers. on for each level X, classifying points as being X or something else. For the most part, these dictionaries are wiped out within machine learning libraries and invisible to data scientists who was the libraries. Now example script. Example script documents many of the topic we will in a realistic setting using the sample iris dataset from the last. It takes several important classifiers, train each one of the distinguished Irish virginical from the other specifics, and then plots the results on a ROC curve. Each of these classifier and the matrix we used to evaluate them will be explained very closely. That's it for the lecture. Thank you for watching.